My name is Nils Roscher-Nielsen, and I work for the Qt company. I'm here today to talk a little bit about Qt and the Internet of Things, IoT, and some of the opportunities and challenges that we're facing as an industry and as a technology. And I think that a lot of the talks both yesterday and today are digging into this topic in a lot of detail. We are seeing different talks on how to integrate, how to write middleware, how to write different aspects of the whole stack that we need to be able to provide good and proper Internet of Things solutions or full IoT systems. Briefly, for those of you who weren't here yesterday, or for anyone that didn't pay close attention, the Qt company, I just wanted to give a brief introduction to who we are and what our role in the ecosystem of Qt is. And the Qt company is the company that is the continuation of Trolltech, that founded the development of Qt in the early 90s. Trolltech, I used to work for Trolltech. We were acquired by Nokia, and we were then acquired by Digia. And the Qt company is now a wholly owned subsidiary of Digia. So it is a separate company focusing exclusively on the development of Qt. And what we do is develop the features, and we are also responsible for the licensing of Qt. So any questions related to that, we can, of course, discuss in deeper or lesser detail if you're interested in that later. We have 20 plus years of Qt experience. We have people still within the company that have been working as developers on Qt from the very beginning, and have a very long, even though the Qt company was founded January this year, and as such is a very new entity, we have an extreme amount of longevity and experience with Qt in the company, and some of the early developers are still working for us, which provides us with a unique ability to see the long lines in what we are doing. And one of the strengths of Qt is clearly that it is not a very young and immature technology. It is a very good and trusted and very mature technology that have been proven time and again over the last 20 years. Okay, so I'll look a little bit today on the Internet of Things, but then what is the Internet of Things and what opportunities do we have? How is this affecting us from day to day? Is this something that's far off into the future? And I was thinking a little bit about what are the different opportunities we have. So I looked around and I tried to see what are some of the day-to-day things that I am experiencing that are truly a manifestation in sorts of the Internet of Things approach to software development. And this is a TV and a tablet, and I only have one TV at home, but I have 3 or 4 different remote controls for different devices connected to the TV, and I'm using them all together, and I'm losing them all the time, and I never know where to find the things that I like, the right remote for the right device, and it's a mess. But one of the things that I'm more and more using is my own phone as a viewport to all of those devices. I have a set-top box that has a very nice phone application. I can schedule recordings, I can change the channel, I can get reminders of shows that will be on the TV, so that I always forget when things are on, so getting a reminder of what's going to play is a really nice thing. And this is actually a Qt-based system, where there is a Qt software running on that set-top box that I'm having at home. And that's not because I work for the Qt company, that's just by chance that the company that is manufacturing the box that our building chose to use. This is based on Qt because that is becoming more and more an industry standard in the set-top box industry. And that phone app is then of course also written with Qt because they choose to use the same technology to implement the UI that they have on all of the devices and all of the screens that they are using. But I'm also I also have other applications on my phone that can access the other devices, that can access the Raspberry Pi that I use from time to time as a multimedia server, etc. So that is something very simple in many ways, but very powerful. Another thing that I have is a GoPro camera. And more of these devices that we are using, they don't provide the full level of features that we expect from them. The GoPro camera I have, it doesn't have a screen. It doesn't have a very complex user interface. It doesn't have, I can't see what I'm recording or what I'm doing. So here, this is just me and some friends bicycling in Oslo. But I use my phone as a gateway to see what's on the screen or see what's being filmed on the camera. And I use auxiliary screens at home, photo slideware devices to see those videos because the camera itself doesn't provide all of that, but it does have a network. So it can stream and it can easily share, and you can use your phone to connect to it, and you can see what's on the camera on auxiliary screens, which is becoming more and more important for these type of devices. My father has in his house a home automation system, an alarm system. There is a special lock that is connected wirelessly to the system. There are smoke detectors, temperature sensors. There's a range of devices that can be connected to the same system, and they're all gathering data, and they're all sharing that data wirelessly, and that is also providing both a web-based and a phone-based interface so that you can access this data. You can be visiting me, or you can be in the summer house, and you can check what is the status of the alarm, what is the temperature in the house. Norway is a very cold country, not like here, so you've got to make sure that the heating is on, otherwise the pipes will freeze in your house in the winter. So being able to quickly access that information is extremely important. So more and more sensors are being connected to systems like this. And we had a brief discussion about this morning, that these types of home automation systems might be a simple gateway and a simple way to make people comfortable with these systems. Because they are going to expand and they are going to be everywhere in the future. And they are already there. In Norway, we've also introduced a law now that over the course of 5 years or 10 years or something like that, I don't remember the number, all of the electricity meters should be enabled, online enabled. They should be a part of the Internet of Things. They don't want to send technicians to your house to read off this meter, how much electricity you've been using. They want to have this information accessible everywhere, easily. They save money by having fewer people going around to people's houses, but this also enables completely new usages of old systems. People will be installing batteries in their houses to buy electricity when it's cheap and use from their battery when it's expensive. You can balance out peaks of electricity usage throughout the day. With electric cars, for instance, if everybody's charging at the same time, it can be a big load on the network, or it can be a big cost if power is expensive at that time. So you can balance those things out by having smart meters connected so that you can actually know when to charge and when to not charge. And the next step of that is even something we're discussing is the smart grid. And we are working with several companies that are doing city automation, that are doing large-scale automation systems where we're talking about not only buying electricity at the correct time, but selling electricity back to the system. A smart grid with a range of electrical vehicles in the market, they can actually charge at night when electricity is cheap, and they can sell electricity back into the system at peak times when electricity is expensive. And you get not a zero-sum game, but you can actually earn money on the electricity from your electrical vehicle. So there's a range of new opportunities here in logistics, for instance, by tracing every single unit in your warehouse, knowing where it is, and having an online, always present knowledge is extremely valuable. So there's a range of opportunities here that are already working and that we can be tapping into if we have the right technology. I was looking a little bit around and trying to figure out, like, what is the Internet of Things for people, and it enables a whole range of new possibilities, and we just need to be able to think outside the box. How can we use these sensors? What is the value of having all these sensors and all of this knowledge if we're not using it for something meaningful? Now, offering people temporary housing instead of calling the fire department when your smoke detector goes off is probably not the right thing to do. But there are a lot of unthought of potential for sure. So if we simplify Internet of Things systems, we can very roughly say that it is a number of embedded devices and sensors all connected, and all of this information obviously leads to the accumulation of large data sets, something we very often call big data. Big data is in many ways no different from any other data that we've been dealing with for years, but we get large and large amounts of it. So obviously we need to manage it in a good way, and we need to be able to visualize it, we need to be able to access it in a meaningful way and draw conclusions from it that make sense from a business perspective. So this is obviously all on in the cloud, but in many ways it is it's a very simple picture, but it's also a whole portfolio of different technologies. So sometimes it might feel more like the heaven fell in our heads when we have to work with all these challenges. There is, when we're going to technology conferences and when we're trying to investigate what are the things we can work with to enable the Internet of Things, there's a number of technologies, there's a number of standards that we're working with, and all of these are hardware standards. All of these are hardware innovations and hardware development, and there's a lot of physical enablers that allow us to access this market. But there's not all that much for software developers. So what are we going to do? And what is happening in our end of the market? And that's something I think is very important to start building better tools for software developers. This is, I don't know if you can see all the data. This is from a Goldman Sachs report on investment in many different areas. It's Goldman Sachs Global Investment Research. And it's showing, I don't know if you can see the top graph, which is traditional capital goods and hardware development. How much is invested in hardware and how much is invested in software. And traditionally, the hardware has been the expensive part, and the hardware has been where the investment was. But now we see more and more of the investments are happening on the software side, and we need to take that into consideration. The number of connected devices obviously swell and grow rapidly, and the number of devices obviously leads to the cost of each unit rapidly goes down. A lot of people are very concerned about bill of materials, and a lot of people are very concerned that they need to have this or that hardware. We're always talking to customers, and they want to reduce costs in hardware development. But more and more, the user experience is what becomes important. So we have to look at the cost of innovation, the cost of bringing something slower to the market might be extremely high. So saving money in the bill of materials might be detrimental to the business model if you're not able to bring innovations to the market quickly enough. So from the same Goldman Sachs, it's a different report. They are identifying a couple of enablers for successful Internet of Things development, which is managing communication, providing good middleware. I know there will be talks about writing middleware with QML here later today. storing and securing data is obviously extremely important in a world where the data is the key to unlocking the value potential and being able to analyze and visualize it. So these are some of the key concerns that we see as well and try to target with our development of Qt and what we look at when we try to further enhance the offering that we have for all of you who want to make beautiful Internet of Things devices. So I'll look at 4 different topics regarding IoT today. And first of all, the connected embedded devices. These are no different from the embedded devices we have been enabling people to do with Qt for a very long time. I talked a little bit about Qt for device creation yesterday, and in this market with cheaper, smaller devices, sensors, etc., it only makes sense to use a tool like Qt, which has a very long history of being an innovative, but also a very small, it's a powerful framework, it's C++, so it runs great on embedded devices. We are also investigating a lot and looking into, together with customers, how we can make Qt even smaller and more lightweight, and have been putting out a number of different innovations already, and we're more than happy to work with other customers as well to see how can you enable all of those devices to run software that you need. But more and more also as there's a whole range of devices that you need to create. Building one application for one device isn't a feasible business strategy over time. You need to be able to build an SDK, you need to be able to build applications that are portable. So being cross-platform is obviously an extreme advantage, but also having all of the enablers of being an SDK that you can provide to the ecosystem and the partners that you have is important. I won't go through all of the value propositions as such, but it's in the slide material, and feel free to contact us regarding this. Now, big data is something we've been trying to estimate for a while how quickly this is growing. And we see that over the course of the next 3 to 4 years, the amount of data being generated every year is going to double from 20 to 40 yottabytes. And it's unimaginable in many ways, but we need to be able to break it down and to analyze it in a good way. So one of the things that we are doing is Qt Cloud Services, for instance, being able to store your data in the cloud in an easy way. We have Ngineo data storage. We have a number of other cloud-based classes that you can easily connect to your Qt-based applications or connect your Qt-based devices to. Managed WebSockets, for instance, allow the streaming of data, the communication between devices, very simply, easily, real-time. And also being able to have scalable applications running in the cloud that are connected to all of your devices so that you can easily analyze and work with the data depending on the data flow. If it changes, you can scale your application up and down so that you can actually manage without halting completely. Another thing I wanted to mention regarding big data is also we have a lot of classes for visualizing the data. We have 2D, 3D APIs in Qt and the underlying technologies to easily take all of that and visualize it, charts, etc. Reaching the end user is something that is becoming more and more important, and I talked briefly about that yesterday as well, that it doesn't really help to provide a good service or to provide a great medical device or a great industrial device unless consumers see the value. And the value, how people perceive value, has changed dramatically over the last 10 years, where user interfaces become so much more important than they were a few years ago. As mechanical engineers or industry workers get iPads at home, they expect the same user interface and the same experience in professional machinery, etc. So being able to see your products not just as hardware or software products, but as services that are available everywhere, I think is very important. So there, a cross-platform toolkit like Qt has some significant benefits, how you can bring that to all devices. One of the key enablers, of course, is Qt and QML. And QML is a really nice technology for making scalable user interfaces across a number of devices. And it's super easy to create the same software service and run it on different devices, have the same back-end running. It can be online, it can be on embedded devices or PCs, and then have various user interfaces running on top of the different instances. You don't need to have the same UI at all, even though it's the same service running. And what is one of the main benefits about productivity and bringing these services not just to all of the devices you need, but you need to do it quickly enough to be relevant. If you are too slow to the market, if innovations are not happening fast enough, that is much more costly than the unit cost of each single device. So a rapid workflow is extremely important, and being able to work closely with designers in the same tools is something that can really allow this. I know there will also be more talks in depth later today about this topic, how you can significantly reduce costs by having designers and developers work in the same tool sets, not throwing away innovation. As I've said a number of times, we are not deprioritizing widgets, and especially in this world of very small devices, a static UI might be useful in many areas. Widget-based, small footprint UIs might be valuable, even though I, of course, have a preference for smooth animated user interfaces with Qt Quick. And being able to integrate with HTML5 is important, as more and more services are also available online, and you might want to reuse the online content and native applications. You want to combine them, and you want to use more and more hybrid user interfaces. One of the examples, I didn't bring it here because it requires a lot of physical setup in the demo area, but we have made a small demo proof of concept setup to show such an IoT solution, which is our weather client, where we have a number of weather measurement systems in our office in Oslo, in some of our offices in Finland and other places. And it's easy to extend and to add new sensors, new data to the system. And that is connected with Qt Cloud services. We have different applications for phones, for desktop, etc., to access this data, to visualize it, and do a lot of different things with all of this. And you can see the structural setup of this here, and that is something that we provided as an open source solution to show, as an example, how easy it is and how you can think about and how to create these types of systems. So that's something that's really nice to look at. I don't know if I have the app on any of our phones here today, but we can download that if some of you want to see it and see how we can connect to and work with that online data. And of course, these systems are not stand still. They are moving very fast forward. All of your devices that we put to the market today, they will be there for a long time. But these systems are growing and expanding, and we will be adding more sensors, more devices to the existing systems. So they need to be extendable, and we need to build systems that are built to scale. We can't start today and thinking that this is how the world will look in 5 years. So we need to be able to build systems that can easily expand. And I think being able to target more markets, being able to target more devices is important. Being able to bring your services to, for instance, cars or set-top boxes or other service streams is something that is a very important value add. And one of the things that is important about Qt in that aspect is that it is actually cross-platform. And a lot of people, they say, oh, we only need embedded Linux for this embedded project, or we only need this or that, or we're going to base it on a specific real-time OS that we're going to use. But in reality, you don't know what the customers are going to ask for in 2, 3, 4, 5 years. And having to rewrite your whole service level, having to rewrite all your code because one of your customers says, we actually have to move to this specific real-time operating system now, is not an ideal solution. So having something that can scale across hardware and operating systems is extremely important. And of course, being a native framework, this is something Qt handles very well. And it's something that we can and have been doing for a long time already, adapting to the changing markets. iOS and Android is, of course, a good example of that. Working with customers on real-time systems such as VxWorks and QNX and Green Hills Integrity are other examples of just that. And I think we've also, just as one example of things that have been changing a lot. So when we introduced Qt Quick, obviously saw the need for fluid UIs and really smooth animated UIs. And we wanted to have OpenGL accelerated hardware as the basis of those user interfaces. So QML was built on an OpenGL-based scene graph. And that worked really well, but there are other markets, and markets are changing, and people are still very interested in the lower end and the cheap hardware. So adding to our portfolio, we added the Qt Quick 2D renderer, something that is able to render the same UI onto non-OpenGL accelerated devices. And of course, this allows us to target a completely new range of cost-based devices. So, to summarize some of the challenges I think we're seeing, creating embedded devices is allegedly as painful as it always was. I don't think that's the case. I think with the development workflows that we have in Qt, with the rapid prototyping tools that we have, and with the seamless integration of Qt Creator with embedded-based devices, this is becoming more and more easy and faster and easier to do. Creating an extendable architecture is extremely important, and create future-proof software. Being cross-platform is part of that. Being a combination of open source and enterprise is an extremely important part of that. Qt is open source so that you are able to see what you can do with it. You are able to change it to your requirements if you need that. But it is a commercial software, and that is important because being backed by a serious company means that innovation is happening quickly. And we've seen that time and again with open source projects that they can pull together and halt and development can stop. And it usually happens according to Murphy's Law at the time when you need innovation to happen the fastest. So being backed by an enterprise, a commercial company, means that there is a guarantee of support and there is a guarantee of us also securing the future of Qt. And having backends for embedded devices is extremely important. The Internet of Things is already here. So being able to connect to the cloud, being able to connect all of those applications that you're writing is something you can easily do with Qt today. And making it reachable by all consumers, making it reachable on all platforms is very important. So that is, big data is the last part of this we've been discussing today. Being able to use cloud computing, being able to use all of the features of Qt, but also Qt being C++ and being an open platform, you can integrate with any and all tools that you also need that is not a part of Qt to work with the devices you have. So I think that's what I wanted to say. And of course the tagline or the general idea is that you can really create unique experiences with really high performance using Qt. So thank you all very much for listening, and enjoy the rest of the show today. Thanks.
Grazie. Ci sono domande?
Yeah, if there's no questions, I mean, we will be here all day. We are here. We have a small stand outside, so feel free to come talk to us. I can take some questions now if you're interested, or we can discuss more throughout the day. We have some demos, not too many, but we also have some very interesting get started papers on different areas of Qt development. So please come by and pick those up, so I don't have to bring them all back to Oslo. Yeah.
Thank you again.
Thanks.
Sorry, I don't remember what is the price for the Qt cloud services. I don't remember. It's free for certain level, free for. I don't remember exactly. Can you please explain?
So Qt Cloud Services is, as you said, that's not a free-for-all, free-to-use service. It's an enterprise-level service, and there is a free trial version of it, and there is a free initial version. It's based on data usage and how much you're actually using it. So up to a certain level, it is free to use. So you can implement your server-side application, your data storage, and your managed WebSockets for free. And then when your business model really takes off and you're starting to get 1 million users and a lot of ad revenue, then you're using enough I/O events and enough data storage that it triggers where you need to start paying something to us. But it is designed in a way that it's not one fixed price. It is for free when you have a very low usage, and as the usage grows, there is a certain price. I can't remember what that is entirely, but we can figure that out on a case-by-case basis, of course. Thank you very much for that question.
Altre domande? Allora, grazie di nuovo. Thank you again.